Between 2009 and 2018, the energy company Axpo expanded the existing plants run by Kraftwerke Lake Limmern AG. The heart of the project was built between the Limmern-Boden Reservoir and Lake Mutt, situated 630 meters higher. The new underground pumped storage power plant Limmern. The new plant has pump and turbine capacities of 1,000 megawatts and harnesses the height difference between the two reservoirs. Construction presented a huge challenge as the whole site lies high up in the mountains. Only the tier-fed installation site at the far end of Glanerland had road and rail access. From here, all necessary machinery, building materials and construction teams were transported up the mountain by aerial cableway. Construction of the 4-kilometer-long access tunnel from tier-fed to the caverns inside the mountain began in 2012. Its diameter of 8 meters can accommodate the heavy equipment to be installed in the new plant. At the same time, the powerhouse and transformer caverns were excavated in stages and secured from top to bottom. The 150-meter long and 50-meter high powerhouse cavern is gigantic. Its entire volume had to be broken out of solid rock. Although some areas were excavated manually, mostly explosives were used. All the excavated material had to be transported out of the mountain. So in a tunnel underneath the caverns, the rock was crushed. A large part of the material was used to build the concrete dam for Lake Mutt on the mountain. The rest was utilized in an underground concrete plant for the structural lining of the caverns. Early in 2012, excavation of the 50-meter high powerhouse cavern was complete. Now the interior construction could begin. The schedule was tight, so many activities proceeded at the same time. The draft tubes for the pump turbines were being installed in the foundations, while at the same time the cavern lining was being concreted. The vault, which was supported only by the rock, was thus transformed into a closed arch, enabling it to withstand the pressure from the surrounding rock. In the turbine generator pits, the concrete foundations for the units were poured on top of the draft tubes, installed previously. In total, over 80,000 cubic meters of concrete were used in the caverns, enough for around 700 suburban homes. A major construction site deep within the mountain. To connect the plant to the power grid, high-voltage cables were routed through the access tunnel to the tier-fed substation. From here, a new 380 kilovolt overhead transmission line was built along the Lintal Valley. The 17-kilometer-long transmission line forms part of the Swiss extra-high voltage grid. 53 new pylons were erected for the overhead line. Construction was a particular challenge, as some pylons reached 89 meters in height. In inaccessible terrain, the construction material had to be carried in by helicopter. While the transmission line was being completed, the heavy equipment transport for the powerhouse was in progress in the valley below. Components such as the spiral casing for the pump turbines were too big to be transported by usual means. At 190 tons, the machine transformers, the heaviest individual items, weighed too much for the 40-ton aerial cableway. So the large and heavy parts were transported directly into the caverns through the now completed access tunnel. The huge dimensions of this tunnel and its 200-ton capacity funicular were specifically designed for these large and heavy components. Assembly of the machine groups then began. The spiral casings have to withstand the huge hydraulic pressure exerted by the water and were fully embedded in massive reinforced concrete. This is where the pump turbine runner will later rotate. The combined thrust bearing for the turbine generator shaft train was installed above the pump turbine. While the turbine generator pits were being completed, the rotating parts of the generators, the rotors, took shape. At around 330 tons apiece, they were too heavy even for the funicular and had to be assembled inside the powerhouse cavern. At the same time, the stationary component of the generators, the stator, was installed on its foundation above the pump turbine. Finally, the assembled rotor was lowered into the stator. During operation, the rotor rotates some 8 times a second and develops the equivalent power of about 3,000 average cars. By November 2015, the first 2 machine groups were fully assembled and the first unit was successfully synchronized with the power grid. While the caverns were being excavated, construction of the upstream pressure shafts from Lake Mutt also began. The shafts were excavated one after the other using a tunnel boring machine. They are inclined at 40 degrees and terminate in the valve chamber, 600 meters higher. Here, the upstream pressure tunnel and surge shaft, a vertical shaft open at the top for compensating pressure fluctuations, were also constructed. From the valve chamber, using a temporary rail system, the penstocks were installed in the pressure shafts. The delivery and installation of the pipes was extremely complex. The prefabricated lengths of penstock were welded together only after being positioned in the shaft. In total, 2 kilometers of penstock were installed over 3 years. The upstream pressure tunnel connects the valve chamber to Lake Mutt. 8 meters in diameter, it's as big as a road tunnel. During 2012 and 2013, the Lake Mutt intake and outlet structure was constructed at the tunnel portal and was later submerged. From here, water flows through the upstream pressure tunnel and the penstocks to the turbines. From the powerhouse cavern, the 2 downstream pressure tunnels to the Limmern reservoir were excavated. All tunnels and shafts for the hydraulic waterways were now complete. For the construction of the intake and outlet structures, Lake Limmern was almost fully emptied. Up to 200 cubic meters of water will flow through these 2 structures every second. Their design minimizes turbulence losses in the water flow. Above the normal water level of the lake lies the Ochsensteffli material handling site with its gravel silos and crushing plant. The excavated material from the caverns used to build the Lake Mutt concrete dam was processed and stored here. From here, the material and all construction machinery were transported to Muttenalp via a second aerial cableway. This can carry loads of up to 30 tons. The aerial cableway leads to the Lake Mutt dam site on Muttenalp, 2,500 meters above sea level. The dam is formed from 68 segments, each 15 meters wide. The entire dam was built over 3 summers. It's around 1,000 meters long and up to 36 meters high. The dam raised the level of Lake Mutt by as much as 30 meters, almost tripling the lake's original capacity. The extent of the building site high up in the mountains was impressive. Up to 150 workers lived in this construction site camp. An on-site state-of-the-art concrete plant produced the concrete for the dam. By 2012, around a quarter of the dam was under construction, and it was possible to imagine the size of the final structure. During the summer of 2013, the dam section on the opposite flank was built. This section features the highest segments. By the end of 2013, around 2/3 of the dam had been erected. 2 years later, in November 2015, the dam was complete. The dam is equipped with highly sensitive monitoring instruments, and the crest allows for pedestrian access. Lake Mutt was fully impounded for the first time in the summer of 2016. The construction facilities had previously been removed. In the powerhouse cavern, the new units are taken into service one after the other. The pump turbines and generators are extremely flexible in operation and can switch between pump and turbine modes within only a few minutes. The machines are monitored in the power plant's control room in Tierfeld. Machine operation is determined in Baden, depending on the electricity market. Having completed this highly complex project, the Mutternalp is now home to a dam at the highest elevation in Europe, and at over 1,000 meters, the longest in Switzerland. It holds back water, enabling the flexible generation of electricity.
Since 2022, the Alpine photovoltaic installation on the dam wall has been in operation, complementing climate-friendly electricity production.
Due to its high level of operating flexibility, the new Limmern pumped storage power plant plays an important role in ensuring grid stability and the reliability of supply in Switzerland and in Europe.